Welcome back to The Explainer. So, today we are going on a totally wild, high energy journey straight into the absolute bleeding edge of automotive tech. We're talking about a reality that feels, well, literally ripped straight out of a sci fi blockbuster. But trust me, it is happening right now in labs and digital spaces across the globe. I mean, just imagine this for a second. What if your car knew you wanted to change lanes before your hands even twitched? Or what if it knew you were falling asleep before your eyelids even felt heavy? Let's dive right into this mind-bending concept, because the tech to link our brains directly to machines, yeah, it's actively shifting from science fiction into actual physical reality as we speak. All right, so here's the roadmap for today. We're starting off with the Gen Z automotive disruption, then looking at perfecting the physical ride, exploring AI as your co-pilot, driving with your mind, and finally we'll navigate the ethical BCI minefield. Okay, part one, the Gen Z automotive disruption, redefining the rulebook. To really wrap our heads around where cars are going, we absolutely have to look at the digital first generation that is just completely tearing up the traditional engineering playbook. And nothing captures this better than Vloris Motors. Their whole mission statement is where luxury meets its speeds. It brilliantly illustrates their vibe, right? This is a brand built from the ground up by young visionaries, not, a legacy board of executives sitting around in suits. Just look at the timeline of their CEO, Anish. At age 12, he's sketching out raw concepts. By 15, he's completely bypassing the slow, traditional clay prototyping that legacy automakers use. Instead, he's building these fully animated, hyper-realistic 3D models using gaming engines like Unreal Engine and Blender. He's literally testing aerodynamics in a virtual space long before a single piece of metal is ever cut. So you can pretty much throw the old paradigm right out the window. We're trading in that static 19th century drawing room interior, the heavy, rigid leather and wood for an ultra-modern spaceship aesthetic. Vloris is swapping out boring GPS screens for hanging LED land maps, exterior paint that fluidly morphs, and get this, totally wild, U-shaped stimulators instead of a traditional steering wheel. Moving on to part two, perfecting the physical ride, focusing on mechanics and comfort. Because before we even touch mind control, we've got to zoom in on how engineers are actually grounding this crazy tech against, well, brutal potholes and violent lateral forces. Here is the crucial point. When standard vehicle vibration magnitude hits this ISO standard mark of 47 meters per second squared, it places drivers squarely in the health guidance warning zone for severe back pain. We're not just talking about a bumpy ride. That level of vibration actually damages your spine over time. So the human body absolutely has to be cushioned better against these massive hypercar G-forces. Enter the dynamic G-force swinging seat. This is Vloris's brilliantly complex solution, using geometry like a SARS linkage and slider crank. Basically, instead of you sitting rigidly and fighting the intense physics of a high-speed turn, the seat fluidly banks and tilts left and right, kind of mimicking a flight simulator. It literally takes the physical strain completely off your body. All right, section 3, AI as your co-pilot, creating the smart cabin environment. Now that your body is physically locked in and secure, let's scale out to the entire cabin where AI bridges the gap between our human limitations and mechanical perfection. Outside the car, AI is taking vehicle awareness way beyond our useless human eyes. It's using thermal imaging to spot pedestrians in pitch-black conditions, handling tailored predictive maintenance, and using generative AI to create synthetic traffic scenarios, which honestly saves millions of real-world test miles. But the truly critical job, that's happening inside the cabin with you. It's like trying to listen to a whisper in the middle of a hurricane. I love this quote because it so vividly describes the massive engineering headache of shock artifacts. Basically, shock artifacts are these messy spikes of noise in brainwave sensors that happen when the car violently vibrates, or even if the driver just flexes a single muscle. To solve this incredibly noisy biological data problem, they use the brilliant three-step ARSA method. Step 1, the AI aggressively filters out all that mechanical and muscular hurricane noise. Step 2, it analyzes the clean data to catch the exact millisecond your brain transitions into fatigue. And step 3, the car actively intervenes, blasting a bright, waking blue LED. The car literally reads your sleepy brain waves and alters the environment to prevent a crash. How cool is that? Which brings us to section 4, driving with your mind, the brain-computer interface. This is where we blow the doors totally off traditional driving and step straight into sci-fi reality. You might be thinking you need a high-tech hospital for this, but no way. Researchers are actively proving this tech in the real world right now using consumer-grade 14-channel wireless EEG helms. They just use these incredibly simple, non-invasive saline sensor pads resting right on your scalp inside standard smart car simulators. Now, what's really fascinating here are the takeaways from a recent UCLA study. They found that raw human thought is just too noisy on its own. When a paralyzed participant tried to move robotic blocks with just raw signals, it totally failed. But the second they paired those signals with an AI camera copilot that inferred visual intent, boom, objects moved in 6.5 minutes. The AI is the absolutely essential translator here. So, the frictionless BCI endgame looks like this. Step 1, the driver simply thinks of a maneuver. Step 2, the BCI instantly reads those specific brain frequencies. Step 3, the hypercar fluidly and automatically executes the physical action. You fuse that AI copilot with the Vloris hypercar concept, eliminate the steering wheel entirely, and the vehicle literally becomes a seamless extension of your nervous system. Finally, Section 5, the ethical BCI minefield, or the true cost of cognitive tech. As breathtaking as this future is, we need to completely shift gears, slow down, and carefully examine the profound risks involved here. The crucial point we have to tackle is the dual-use dilemma. This is the concept that the exact same neutral BCI technology capable of restoring movement to someone who is paralyzed could, in the wrong hands, strip away our fundamental mental privacy. It's a tool, right? But how society chooses to apply it will dictate whether it becomes a medical miracle or a terrifying breach of our own minds. We are looking at fierce, ongoing industry debates right now about everything from irreversible animal surgical trials and unexpected side effects like gambling addictions to some massive real-world implications. Algorithmic transparency. If the AI makes a split-second stop based on your brainwaves, can we even audit that decision? Neuromarketing. Imagine corporations targeting your subconscious cravings. And societal stratification. What happens when an unbridgeable gap forms between those who can afford cognitive enhancements and those who can't? And this brilliantly illustrates the terrifying legal ambiguity we are facing. Think about it. A smartphone breach means hackers steal your photos or your texts, which is bad enough. But a BCI breach? Hackers could potentially extract your deeply personal subconscious reactions. Revoking your consent isn't just about protecting your camera roll anymore. It is literally about guarding your subconscious. So, as we stand on the edge of this lightning-fast frontier driven by Gen Z innovators, I want to leave you with this final, vital thought regarding your own future autonomy. When the day finally arrives for you to sit in that swinging hypercar seat, look at the dashboard and see the terms and conditions for a car that connects directly to your cloud-synced brain. Are you truly ready to check, "I agree"?